Hi, Mr. G here. In this lesson, we're going to learn how to use your homemade balance now that we've added some upgrades to it. When we used our mass balance before, we could successfully get a general estimation of the mass of our object using standards of measurement, those standards being our U.S. coinage, because we knew the mass of each coin from the U.S. Mint's website. However, now that we have a little more background knowledge, that being the necessary understanding of significant digits, accuracy and precision, and experimental error, we know that with our upgrades of having graduations on our mass balance, we can make much more accurate and precise measurements. However, we need to learn a little bit more of how to use those graduations on this device. And that is what this video will instruct. Our scenario is that we are an organic chemist working for some type of demolition squad, whether that be the SWAT team or the U.S. military, and we've prepared some trinitrotoluene for a test exercise. Well, trinitrotoluene is the chemical or more common name for the explosive TNT. It's important for us to get the mass because we can then calculate the explosive ability of the substance. And so what we've done is what we did before. We used our mass balance and we placed our prepared substance in the one pan and then got as close to the middle of the, or leveled it out as much as we could using our standard masses, which is our U.S. coins. So what we need to do now is calculate the mass of our coins. And we have 4 quarters here. So I'll say 4 quarters, 1 nickel, and 1 penny. Let's blow up our chart here for a little bit so we can read the masses and do our calculations. So 1 quarter is 5.670. So we're going to multiply that by 4. Preserving our significant digits, which is 4 significant digits, giving us 22.68 grams. We're then going to add our nickel to that, which is 5.000 grams, and our penny, which is 2.500. We're going to add those up to get our mass. Our vertical line goes right to this side of the 8. And we'll use our calculator. And then get a mass of 30.180 grams. So we know that our mass with our pointer in this condition is 30.18 grams. With this, let's go back, minimize that. What this is essentially telling us is that our TNT is just slightly heavier or more massive than 30.18 grams. But we'll get back to that. We need to move to our next stage, which again was 30.18 grams. Not what that was. I can look here real carefully. It's 2.268 grams. Our pointer was just to the right. We had 30.18 grams. which is adding just slightly enough weight to do our best, really, to try to get it right at the middle mark. But the smallest coinage we have is going to put us a little bit over. So we can take our previous mass, which was everything but the dime, and add that to the mass of a dime. So we'll go back to our previous slide. Our vertical line goes there. We'll add those together. We get 32.448 grams. So I know that our mass with our pointer in this position Well, this is where we need to focus on our graduations. So let's take our numbers, our measurements, and convert them over to another screen. We know when the pointer was to the left of center, we had 32.448 grams. And then I'm going to put here heavier, because that's when that mass was a little heavier than the TNT. And we know that that's when it was a little lighter than the TNT. So, what we want to understand is how we can utilize these graduations. We should understand that these graduations here and here are equally distanced apart. And this, in red, is our center line. And what we have are two certain values. When we're given a ruler, like the ruler A in our initial lesson on significant digits and measurement, our basic ruler had two certain digits. And when we just had two graduations, we needed those two certain digits to make a very basic measurement. And so all we could do was estimate in between them. But we have some more graduations in between to work with to help make our measurement even more accurate. So what we need to do is we actually have to understand what these graduations are. So what we know is that our smallest graduation, our farthest left, is 30.18 grams, whereas our largest is 32.448 grams. And if we do our counting, we know that there are 10 increments in between these graduations. So what we need to do now is we need to understand what the value is of these smallest graduations. And the way that we do that is that we need to find the difference between our two extremes. In other words, we need to subtract. So we take our greatest value and we subtract away our smallest value. I'm going to do that on my calculator right now. And I get 2.268 grams. In other words, the difference between these two values is 2.26 grams. So to find the value of each increment, since there's 10 spaces in between, we need to divide this number by 10. So the value of each increment is 0.2268 to 3 sig figs, and this is going to help us to determine our actual value, or our most accurate value, of our mass of TNT. So how do we do this? Now that we know what each increment is, what we want to do is we want to understand the big picture. We know that in this stage, our TNT was just slightly lighter than 30.18 grams. And in this stage, our TNT was just slightly heavier than 32.448 grams. The 32.448 grams was on this side, and the TNT was on this side. Over here, the 30.18 grams was on this side, and the 32.448 grams was on this side. What we want to do is understand that the two substances have equal mass when the pointer is at the midline. So we want to pick whichever one of these has the pointer closest to the midline. Well, which one is that? It's this one. We can see that the pointer is pretty much 1, 2 graduations away. Over here, it's 1, 2, 3 graduations away. So, the next step is to use a little bit of addition or subtraction, utilizing, my pointer's not working, utilizing this increment number to determine our mass. Since we understand that this was where we really wanted our TNT to be, we should understand that we want to count our increments from the true line. Therefore, when we're making our estimation, we're estimating that our value was 1 increment, 2 increments, and somewhere in between from our true value. So my estimate will be about 2.5 increments off from the true value. Okay? And since this is our scenario that we picked, we know that it was off by being lighter. That means when we adjust our measurement, we're going to adjust by subtracting from our heaviest measurement. So the way that we do this is we take our increments value and we multiply it by how many increments we were off by. I estimated 2 increments, and since I'm allowed, I was certain that it was 2, and then I estimated, because I'm allowed to estimate, that it was at about a half. I can then say 2.5 times the value of the increment, which is 0.2268. And I get 0.567. What's important to understand here, and a little bit confusing, is that the significant digits we go by are these. Remember in our significant digit rules that there was one rule that said counting numbers have infinite sig figs. And what we're essentially doing here on our graduations is that we're counting here, and that these graduations are counting numbers. So we consider them only in this circumstance to have infinite significant digits. So what I do is I take this value and I subtract it away from this value. Oops, not that value. I subtracted away from the value that I calculated, this value. And I'll get my most accurate measurement. Which ends up being 31.881. And since it's going to around here, we just leave it as 31.88 grams of TNT. And that is how you properly use your mass balance to the proper number of significant digits. There's a lot of steps, but once you get used to using it, it's not so bad. And this is why, my friends, I've had you practice so many problems with significant digits and mathematics.